Alright, so today we start talking about polygons. Polygons I know you have seen before. My daughter's in 7th grade. I've been working with her on polygons for the last couple of weeks. That's what they've been doing. So I know you've seen this stuff before. Lesson objective. Instead of doing an objective, I just defined the word polygon. So polygon, it's a closed figure made of at least 3 segments. That's all a polygon is. Okay, and then we do some more definitions. The side of a polygon is just one of the segments that form the polygon. So example, this right here is just one of the sides of the polygon. That's all the side of a polygon is. Vertex of a polygon, it's a common endpoint of of 2 of the sides. Where do 2 of the sides meet? That's a vertex. Simple like calling it a corner, but the math term is called a vertex. A diagonal, it's a segment that connects any 2 non-consecutive vertices. So if I draw a line that connects 2 non-consecutive, consecutive just means in a row, so I have to skip at least one vertex. So there's vertex, skip this vertex, and draw the diagonal between those 2 vertices. So that is a diagonal. It's a segment that connects any 2 non-consecutive vertices. Regular polygon. We've talked about these when we talked about equilateral and equiangular triangles. All it means to be regular is that it is both equilateral, which means all the sides are congruent, and it's equiangular, which means all the angles are congruent. So if a polygon is regular, it means all the sides are the same length and all the angles are the same measure. Okay, concave. What does it mean for a polygon to be concave? It says when part of a diagonal contains points in the exterior of the polygon. All that means, so let's say I try drawing in the diagonals of my polygon. If I draw in a diagonal and any part of that diagonal lies outside of the polygon is concave. So we'll do examples in class. Think about what that means. If I draw a polygon, any kind of polygon, and I try drawing in all the diagonals, if any part of any of the diagonals lie outside of the polygon, it's concave. Think about this one. Look at this polygon right here. If I draw in all the diagonals, is any part of those diagonals going to be outside of the shape? In this one, it's not. All the diagonals, like this one, are going to be contained within the polygon. And that leads me to the next one, convex. If my polygon is convex, then no diagonal contains exterior points, which just means every bit of every diagonal lies inside the polygon, like the one up the top of the page. Alright, do me a favor, write this here. All examples below are regular and convex. So all these shapes, they are regular and they are convex. We're just going to name some polygons. Okay, most of this should be review. If it's got 3 sides, it's a triangle. If it's got 4 sides, it's a quadrilateral. If it's got 5 sides, it's a pentagon. 6 sides, hexagon. 7 sides, heptagon. 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon. We're going to skip 11 and we're going to go to 12, dodecagon. Anything over 12, we just use the number to say what it is. So let's say my side has 16 shapes, we just call it a 16gon. If it's got 21 sides, it's a 21gon. And so on. Alright. Important piece. Do me a favor. Right off to the left. Must be convex. So this rule that we're about to do right here, it only applies if my shape is convex. Alright. We're going to start with the triangle. Let me get it there. Okay. In this triangle, there is only one triangle that I'm pointing at. And we should know by now that if I add up all the angles of a triangle, it has to be equal to 180 degrees. So a triangle has 3 sides. There's only one triangle that I'm pointing. That'll make a little bit more sense in a little bit. There's only one triangle that I'm pointing at. So all the angles of that shape must equal to 180 degrees. Well, now we're going to look at a quadrilateral which has 4 sides. Okay. Now think about what we're going to do. Notice I draw in a diagonal. When I draw in one of the diagonals, how many triangles do I now have in this picture? I have one triangle on the top and I have one triangle on the bottom. So my shape had 4 sides. I draw in a diagonal and I create 2 triangles. But now remember, for every triangle, there's 180 degrees. So in this one, I have two triangles that I was able to make. Each triangle has 180 degrees. So quadrilateral, if I add up all the angles of a quadrilateral, it's 360 degrees. Okay, so we'll start seeing a pattern here in a little bit. Okay. Now I go to a pentagon. Pentagon has 5 sides. When I start at the same point and draw in the diagonals, notice I can make 1, 2, 3 triangles. So my pentagon has 5 sides. I was able to make 3 triangles. For every triangle, there's 180 degrees. So a pentagon, if I add up all the interior angles, is 540 degrees. Okay, hexagon. Hexagon here has 6 sides. Notice I'm able to draw in 4 triangles. So for every triangle, it's 180 degrees. So it's 720 degrees in the shape. Now, do we see a pattern here? 4 sides, 2 triangles. 5 sides, 3 triangles. 6 sides, 4 triangles. The rule is, notice the number of triangles I can make is 2 less than the number of sides. So if I know the number of sides in my shape, all I have to do is subtract 2 from that. That'll give me the number of triangles I can make, and then I can multiply that number by 180 to figure out what the interior angle sum is. Okay, let's do some. So the first one, find the sum of the interior angle measures of a convex heptagon. Well, if it's a heptagon, it has 7 sides. Well, if it has 7 sides, I take the number of sides, which is n, subtract 2, so 7 minus 2 gives me 5, so I can make 5 triangles. Well, if I can make 5 triangles, and each triangle has 180 degrees, the angle sum is 900 degrees. Okay, let's go to this one. It says, find the measure of each interior angle of a regular 16gon. Well, if it's got 16 sides, I take 16, subtract 2, means I have 14 triangles. There's 14 triangles that I can make with this shape. Note, they want the measure of each angle, so that's kind of different. So, if it's got 14 triangles, and each triangle has 180 degrees, 14 times 180 means that the sum, the interior angle sum, is 2520 degrees. So that's what they are if I add them all up, if I add up all the angles of a triangle. If I add up all the angles of this 16gon. But because it's a 16gon, it's got 16 sides, so it'll have 16 angles, and it's regular, so they're all the same. So if this is what they all add up to, this 2520, and there's 16 of them, how can I figure out what each one of them is? I just take the sum and divide it by how many that there are, which tells me that each one must be 157.5. Alright, let's do another one. So, find the sum of the interior angle measures of a convex nonagon. Well, I got to remember what a nonagon is. A nonagon has 9 sides. So if it has 9 sides, 9 minus 2 is 7. So it has 7 triangles. So 7 times 180, the sum is 1,260. Last one. Find the measure of each interior angle of a regular dodecagon. Okay, a dodecagon has 12 sides. So if it has 12 sides, it has 10 triangles. So 10 times 180 gives me 1,800. So if I add up all the angles in this dodecagon, it's 1,800 degrees. But they want to know what each one is. Well, if there's 12 sides, then there's 12 angles. So 1,800 divided by 12, 150 degrees. So each one of the angles is 150 degrees. All right, come to class prepared and ready to discuss this stuff more in detail.